Good evening, everybody.
Good evening.
I heard two people. Good evening, everybody.
Good evening.
All right, that's more like it. Hi, my name is Ray Andrade. I am LMU's programming librarian. So on behalf of the entire library team, I wanted to welcome everybody to the first faculty pub night of the spring semester. So I haven't seen you recently, so Happy New Year. Happy spring semester. So for tonight's event, we're welcoming Professor Tom Ford. He's going to be talking a little bit about the Palos Verdes Kelp restoration project. So before we actually begin the program, just a couple of words about Faculty Pub Night. So for those of you who haven't heard, Faculty Pub Night is not for faculty only. So I think I do see some students in the audience, so thank you for being here. Please spread the word that it is for students as well. And we do have booze over there, so it's not necessarily 21 and over. We do card people, so don't try to be slick if you're not over 21 yet, okay? So something else about Faculty Pub Night, it's a casual event. So during the talk, please feel free to go get some more food and drink at any time. Okay? Another thing is, if you notice on your chairs, there is a feedback form. If you fill out that feedback form that is being modeled by the library dean, Chris Brantolini, if you fill this out and if you include your email address, you will automatically be entered into a drawing for a $100 Amazon gift card. Might come in handy till they buy half a book, right? Okay, so let's get this show on the road. Without further ado, I would like to introduce Dr. John Dorsey from the Seaver College of Science and Engineering to introduce tonight's speaker. Dr. John Dorsey.
I was told I have to use this microphone even though people can hear me over in the Marina Del Rey with my voice. So here we go. First of all, I'm really happy that Tom's the first off the block with this pub night, because Tom's a great guy. He's done a tremendous amount of work out in our ocean and oceans on the East Coast there. So let me tell you a little bit about Tom. He's got one of these guys that has a resume about as long as your arm. So I just want to sit up here and read all that stuff. But essentially, he is the director of our Santa Monica Bay Restoration Foundation and Commission, and that's a national estuarine project. And as director, he's got a lot of projects going on, and the Kelp project is near and dear to his heart. These guys are located on campus. They're just right over here in the Prairie Annex. That's where most of the staff are literally squeezed in the trailer there. And a couple of their staffers are down in the State Building in downtown LA. And most importantly, the foundation, what they do is they hire a lot of our students, not hire them, but they put them on as interns. And so we've had a huge collaboration with the Santa Monica Bay Restoration Foundation folks, through Tom and through some of the staff back there, working with our students, putting them on different projects where they're getting really valuable information and an experience on how you do really applied, important work. Tom's also co-director for the Center for the Study of Santa Monica Bay, and he's in part-time LMU faculty, so he teaches Introduction to Environmental Science. He has, before he became director of the Santa Monica Bay Foundation, he also was a director for the LA Waterkeeper. And he came up the ranks there. He was there for a number of years, ultimately to become the director. And what I really particularly thought was pretty interesting is that for a couple of years, he was a Narragansett Bay shell fisherman. So, I think we got a fan right here. So that's pretty good. Tom, he has his BA for biology from the University of Rhode Island, so I guess you're an East Coast transplant of sorts. Well, you can still like it, okay. It's okay. And also, he got his marine ecology master's in marine ecology from UCLA over here. So, like I said, kelp is near and dear to his heart. And kelp beds are iconic on our California coast. And if anybody who's ever, any of you students ever dove in an actual kelp bed? 1, 2, okay. Tropical reefs are great, but we have an amazing ecosystem in our own backyard called the kelp forest. If you've ever been about 80 feet down and you look up through all the kelp plants rising all the way up to a huge canopy on the surface with the sun filtering down and whole stacks of fish, all at different layers, and the lush undergrowth and all the invertebrates, they're truly an amazing sight to behold. And we had a lot of this on Palos Verdes Peninsula. We had extensive forests. We lost them all during the 50s. Tom's going to be telling you how we got them back, how we're getting them back through the efforts of pioneers and then Tom's crew and his studies. And it's truly, truly an amazing marine ecosystem that through the foundation we're getting back into Santa Monica Bay where the rocky areas are. Finally, Tom lives right over there. Santa Monica with his family, and he's rumored to surf, travel up and down the beaches. I've not seen my beach surfing, but you're welcome to come. We might give you a few waves. They're nice, okay? And with further ado, I'll present Tom Ford.
Thank you, Ray. And thank you, John. Appreciate your warm words. Is that level okay for everybody? Because it sounds very loud up here. Because if they can hear John down there, Malibu's going, what is that? Because I'm from New England, and we got a big mouth. Thank you all for showing up tonight. I'm very pleased to present this work to you. John is correct. It is very near and dear to my heart. I can't believe at my age, to reflect back, that it's been almost 20 years that I've been working on this project. I want to thank Carol and John and Ray for having us here tonight at Pub Night. I'm joined by my colleagues because as much as I stand in front of you tonight, this is a reflection of the work of a lot of people. And hopefully that'll come across in the presentation this evening. But most significantly, I have Heather Burdick, who's here in the back row. Wave, Heather. She is our current project manager, has been with us now for about 6 years, doing an incredible job leading the charge. Armin Barilotti and Parker House recently joined the team and are already contributing very significantly, as well as my colleague Melody Krups. So, John did an excellent job sending this in. So I only saw a couple of hands go up. So we're going to help set the mood with the first few slides to help you see what it really looks like down there. So this is about 50 feet down, looking up towards the top of the water column. And this day in particular, the current was ripping pretty strong. So tough on the scuba divers, great for the fish, especially the little ones that you see there, which are planktivorous. And the reason why the kelp seems to be awkwardly joined is because it's actually corkscrewing in the currents. Not every day out there is that pretty, but most of them truly are. Here I am in about 20 feet of water looking up through the canopy off of Palos Verdes a few years ago. And it isn't just algae and a few fish near the top. As John stated, this ecosystem starts on the rocks, extends up to the surface. Historically, along the mainland coast to depths of 85 feet, we still see giant kelp growing at depths like that off of the Channel Islands and in the offshore areas, and in a few exceptional years, and in a few exceptional places, maybe down as far as 100. There's a few kelp bass, a mid to high level predator in the system. The kelp forests are a place of food. They are also a place for shelter for many of these species, and the Southern California giant kelp forest community is roughly floating around 700 to 750 species, 240 or so of which are considered ecologically significant, and in this case, a lovely giant kelpfish, my favorite, but he was probably on his commute, because camouflage to red algae in this case, not the brown algae. And of course, you have moments like this. And when they're little, they follow you around like a puppy. And you think it's your buddy yanking on you, and you look over and there's a seal that's like tugging on the back of your wetsuit, going like, do you play or do you just lay there? And of course, we're scientists, so we love to collect data. We love to collect our consistent values and measurements out there to assess what's going on. This is how we spend much of our time exploring this forest at this point in time with the advent of open circuit scuba. But if we go back in time, they didn't have that luxury. And most of the interest in kelp forests 100 years ago were for their value processed, removed from the ocean, and used as fertilizer. So in 1911, with the advent of World War I and the need to find a localized source of fertilizer for the burgeoning breadbasket that was Central North America, the U.S. Department of Agriculture said, okay, we need somebody to go survey it. A team from the U.S. Army got in rowboats, and they worked the entire West Coast, all the way up through Washington in 1911 and 1912. They sat there with sextants, they worked off the boat, they worked off of prominences like this off of Palos Verdes, and drew up these maps for us as how much kelp was off the coast. Question, was it accurate? Was it any good? Is that a good assessment? Well, Magellan did a pretty good job with sextant in his hand. So did these guys. We put it into a modern satellite GIS data layers and found out that the isobath for the outward edge of that kelp really fell across about the 100-foot or so depth profile. So really right where it should have been. So we felt that this was really a high confidence set of data that we could pull from. And because of the various interests in kelp forests, for their fisheries resources, for the kelp itself as a component of some of the beer that you're drinking tonight, for medical research, for augers, and various things, we've had a broad interest economically and technologically in what we can extract from the kelp. And over time, what we see is from 1911 through 1959 in this time series that the kelp is going, gone. You may also see this spider leg starting to extend off of the peninsula. That is the outfall from the Joint Power Sewage Treatment Plant, which comes out at White's Point. Roughly 200 million gallons a day of water still coming out of that pipe at this point in time. And you can see the construction of the early breakwater for the Los Angeles, LA Port Harbor Complex. So there have been some profound changes off of the coastline. That time series continues in this suite up until about 1980 or so, and at that I lose the connectivity of this projection. But we do have other data that is still coming in the door. And if we take those plots, those polygons that you saw on those maps, put them in a simple bar graph, you can see where we were at in 1911, 1928, 1945, and where we've arrived. And the one thing that I think is important for you to remember as we move forward is that in the 70s, there was a near decade-long effort to get rid of the sea urchins off of Palos Verdes and to get the kelp back. In the late 60s, Dr. Wheeler North, who was certainly a maverick at this thinking, had teams of volunteers that were swimming around with hammers, smashing sea urchins, and then that wasn't moving fast enough. They started pouring lye out onto the ocean floor to just kill the urchins and questionably much else with it. No longer a legally permitted process. But they were fairly effective at bringing the kelp back. In that case, there were no standing adults left. There was no reproductive capacity left off of the coast, and they were bringing in plants from Malibu and going out to Catalina and collecting kelp plants that were small adults on rocks and bringing them back to the peninsula to try to get it restarted. Even with a decade, volunteers, lye, and that effort, they didn't get as much done as they had hoped. They ran out of time, they ran out of funding, and they didn't have a chance to stick around and get it back. But a noteworthy effort, and my communications with Wheeler before he died about 10 years ago now were really helpful sitting down with him. So then what went wrong? And this is where we start to frame up coastal management in Los Angeles and kelp forests as part of that. In short, from 1945 moving forward, 8 million people approximately have moved to the neighborhood. It's like having a cocktail party and you wake up on New Year's Day, your kitchen is kind of trashed. Things have changed. So we paved it over. We've altered the way the sediment, the water, any number of nutrients and other important compounds move around across this landscape, how they move offshore. You saw the sewage treatment plant outfall that I pointed at. There's one of those there. There's another one right here in the middle. We also have 3 coastal power generating stations, which according to the California Energy Commission, suck up into the pipes and put back out into the sea something approximating 112% of the volume of the bay every year. So there are a lot of ongoing stressors. So a guy like me looking at the ecology in that context, and now, as you'll see when I get towards the end of the talk, some more of the stressors that are a growing concern regarding climate change, and how does ecology fit into these types of physical, chemical stressors, and do we or can we ascribe which one of those stressors may be the dominant force in defining the structure and function of these kelp forests. So we'll see how well we did in getting there. So it's not just Palos Verdes. Though Palos Verdes sits about dead center in that map, and it truly is the large, central, rocky feature in the Southern California Bight, which is roughly extends from Ensenada, Mexico, all the way up towards Point Conception near Santa Barbara. And there are over 4,000 hectares of rocky reef in a barren state along the Southern California coast. So there's a lot of ground to cover. There are a lot of places that used to be dominated by giant kelp forest communities, which are now in an alternate stable state, which are urchin barrens. Which is why we cry this on a few occasions, especially on a day when it's cold and wet and rough out there. And we're going back down for our third hop of the day. So this is what the floor starts to resemble in an urchin barren state. And as much as it's not just a Palos Verdes thing here in Southern California, it is also a global phenomenon. I am working in collaboration with folks from Norway, Canada, Japan, New Zealand, Tasmania, Australia, growing number of people interested in South Africa as they're watching their kelp forests turn into urchin barrens and are trying to figure out how to get those ecosystems back, preserve the fisheries and the economies associated with them. For some of these countries, it is a food security issue. Not just a trade issue, but a food security issue, and they're trying to figure out how to handle this problem. And to give you an idea of the scale of this problem off of Palos Verdes. In 2010, my colleagues with the Waterkeeper and I, we went out there and we swam every square inch of the perimeter of those red blobs that you see up there. And you know what? We live in a wonderful technological age. I have a genius computer in my pocket. I've got satellites that can detect things from near orbit, but when it comes to kelp forests, it's just up to us, because there's just no way to get any gear through there. It gets tangled. The signals from satellites can only penetrate maybe a meter or so. So to get that done, scuba team on the bottom, intern on top, kickboard, GPS unit, we float a buoy, they hit the button, they follow the bubbles, float a buoy, hit the button, and we can paint the picture. So what it comes out to, all that red spot is 61.5 hectares, roughly 150 acres, and it's just a little bit bigger than the entire campus of LMU. So if you can think of this campus, if you're familiar with it, and then cover it with purple sea urchins, like paving stones, that was the situation that we encountered when we first started doing this work. So we kind of were scratching our heads. We had had some success with efforts off of Malibu. We had people that we worked with. We had the knowledge to help inform our success from earlier efforts in the 70s, but this was a fairly large undertaking, and we knew we were going to have some very big challenges in front of us. So what do you need when you have a big project that you need to get off the ground? Right? You need money. You need permits. You need colleagues. You need folks that have those expertise and those skills that they can bring to the table to help you. We knew that we were going to encounter some politically stiff winds on this as the fishing community, namely sea urchin harvesters who make a living collecting sea urchins, weren't too open at the early phase to, so what are you guys proposing to do? I'm like, well, we're going to go out there and take all the urchins. And they're like, I do that, kid. Oh, you guys having a seat? Very good. So, a couple of the basics. I said, hey, there's urchin barrens all over the place. We want to fix them. The question that came back from a scientific perspective was, well, what is an urchin barren? What are their values? What are their characteristics? Tom, you're telling me you don't like them. You think they're bad. That's really a pretty weak rationale. You know, what can you tell us about urchin barrens? And what can you tell us about the kelp forests that still exist on the peninsula? So this became a first order question for us, one of the first things that we had to answer. So we set up this sampling regime with our colleagues with the Vantuna Research Group at Occidental College. And we have 10 sites within existing kelp canopy areas in green, and 10 sites within these red blotches that are the barrens. And we were going to swim around and count up all the stuff that we could confidently count up, do over time, have a good methodology. And the findings of that resulted in a report and some presentations that we gave at a few conferences along the way. So Jonathan Williams, the lead author on this for this effort, and Jeremy Clace, who's now professor at Cal Poly, were really the keys for a lot of the statistical analyses on this work. So I don't want to get too lost in the details But these were some critical parts of the structure and function of the kelp forest that we were interested in. Crustose coralline algae, CCA, the pink stuff that's scaly and on the rocks for any of you that are familiar with it. Purple urchins, macroalgae, another term for kelp, red sea urchins, California spiny lobster, sheephead, which is a fish, California kelp bass. So we used them because we knew they were important. We use them because in most cases we have a good handle on their life history. We could understand what a fish of that size meant. We could understand what urchins of that size and number meant. And we figured it was time to compare and contrast these critical groups. So the crustose coralline algae being the first one here, and what we found out, barrens to kelp forests, was there was a very significant difference between them. So not the same. Not the same at that basic level. When it came to the urchins, well, it's an urchin barren, dominated by urchins, and there's less in the kelp forest, like, thank you, Tom, the least informative slide I've ever seen in your talk. But, welcome to science. Sometimes we do it like this, right, to get it done. So I said, yeah, I'm not making it up, and yep, those are barrens, and here's how you can see that. And yes, if there's a whole mess of urchins, there's very little kelp because they abrade it off the rocks with their spines. They consume it. They are characterized often as an herbivore, but when they are eating juvenile kelps and killing them, well, that's predation. That's not grazing. And when hundreds of them mass an adult kelp and they cavitate its hold fast and climb up it and tear off all the fronds and stipes and kill it, that's, again, predation and not herbivory. Red sea urchins, they're the friendlier of the two. They're also the one of great commercial interest for the fishery. They behave differently than purple urchins when things get stressful. We don't see them get up on the move. They don't cavitate, hold fast. They don't move in these grazing fronts that we associate most classically with purple urchins, especially here in Southern California. And one of their predators, the California spiny lobster. So there it is. We do know what they look like. We did look for them, and we found 0 lobster in barrens. But if they prey on urchins, and there's thousands, if not millions of urchins to be had, why wouldn't there be a predator there? This is one of the subtleties that I hope you guys can catch tonight. If I'm an urchin, and there's nothing inside me worth eating because I've eaten nothing, why would you as a predator bother taking the time, risking predation yourself to consume me? And that's pretty much what we're looking at. And you'll see some more later in this talk, that the urchins in these barrens are just empty shells. The sheephead, similarly, they prey on urchins. These guys don't have the luxury of the tool usage that the otters do. Neither do the lobsters. It comes down to geometry. They need to be able to sneak up over that spiny ball, flip it over real quick with their legs, if they're a lobster, with their jaws, if they're sheephead, and then crunch away at the vulnerable mouth of the sea urchin. The kelp bass do try to eat some of the urchins that we have smashed open with our hammers, but they're not very good at it. They have a prominent lower jaw. It's built for sucking in larger things, and they kind of fumble with it. It would be like if I gave you 2 chopsticks and one of them was that long. This doesn't work very well. So the values from all this. Kelp bass biomass. Interested in them because they are a higher level predator, and this would be indicative that we're not just restoring kelp, but we're restoring several layers, trophic structures within the community, that we're actually getting energy from the bottom up, and it's revitalizing the whole community. And we expected to see 410% increases with them, 200 for the sheephead, and 267% increases overall for all the fish that were out there. And by the time we got that work done, people said, okay, good job, nice job, kid. Okay, we're getting closer to giving you the okay, but we're very nervous about how this is going to affect the fishery. The red sea urchin fishery is a big deal in Southern California. It is worth $10 million to $12 million in a good year, kind of averages out around $8 million or so. And so we knew that we were going to have to figure out if the urchins by number versus some other characteristics in these barrens and in these kelp forests could be quantified. So this resulted in a nice publication for us in the Ecosphere. And what we figured out was that if we could put the kelp forest back, we would provide more food, more forage, more nutrition for the remaining urchins, and that they, doing what urchins do, put the majority of that energy into their gonads rather than in somatic growth. If they get some food, they don't sit there and just go bigger, 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 bigger. They're like, there's going to be a party in 6 months. I want my gonads to be ready. I'm not going to blow this. And for some of them, they do that a couple times a year. And that's their story. That's how they get it done. So, we collect a bunch of urchins from inside the barrens, inside the kelp forest. We measure their size. We weigh them. We look at the then weight of the gonads versus the weight of the overall urchin. And what we are starting to generate is called a gonadosomatic index. For organisms that do this, this is a good way to quantify how healthy they are, their condition. We look at the condition of the gonads over the years. After opening up thousands of these, we've gotten pretty good at going like, well, that's a good one, I would eat that, versus those are kind of mealy, little necrotic, don't look so yummy. I might not want to pay $30 a plate for one of those at a local sushi restaurant. So we start combining a few of the factors. We looked at the red urchin test diameter in the kelp forest versus the barren. In the kelp forest, they were larger. No big surprise. There were more of them in the barrens than in the kelp forest. Also not a surprise. So the density, size, structure were coming out as we might have predicted or as we might have hypothesized. And then we started getting in a little bit more narrowly as to how this work might benefit the fishery, might benefit the fishermen. And what we were able to show is that everything to the right of that red line is an urchin that is large enough to enter the fishery. If it's got a good condition, the urchin fishermen will be able to identify that. They can harvest anything to the right. Any of the little open circles that you see, kelp forest urchins. The little gray circles were the urchin barren urchins. And when I started talking with the fishermen, I was like, so hey guys, you ever fish over here? And they're like, no, that place sucks. There's nothing there. I was like, right, I know that. And then I showed them why I knew that, and they were like, okay, kid, can I keep this? I'm like, oh yeah, man, we wrote it up and everything. You know, we're pretty proud of it. We're excited that we figured out something that might be helpful. So then we computed this out. Take the abundance, the diameter, you take those values for the gonad size, and we've tried to figure this out as best we can. And it ended up adding up to about 883% potential increases for the fishery for every unit of area that we restored. So this was a game changer for the California Department of Fish and Wildlife, who permits that fishery, who permits our activity, who are responsible for the management of the publicly held resources in the state of California off your coast. And they went, well, okay, we'd be interested to see if you can make that happen. And we were like, we are charged to do it. So, off we go. So, what are our results? Where do we end up? And hopefully, I will be able to convince you that we're moving along pretty happily. And speaking of moving along, if the audio's on, this might be okay. It's good. So that is a rocky reef off of Palos Verdes, and about 15 feet of water, covered with sea urchins. The higher up towards the surface we go, the more wave energy. It limits the activity and mobility of the urchins. They'll get dislodged by a powerful wave or swept by algae swinging by. Once we get down to 20 feet in depth, that's really not the case. Here we are, moving along at the pace that we move along at. Selectively hand culling the sea urchins on the bottom using geology hammers. And within a few weeks, we start to see responses on the bottom like this. And within a month or so, we start to see responses like that. So I don't know how many of you may be really familiar with the Palos Verdes Peninsula, but right off the frame up to the right would be Rocky Point, which is, if you looked out from here on a clear day, you would see that prominence. This run coming down extends from Lunada Bay to Honeymoon to Christmas Tree, a section called Marguerite, which is named for the road that's right there, Underwater Arch Cove into Hawthorne, and it's roughly about 6 kilometers linear of the coastline up there. And the total area that we restored since 2013 to September 2016, 36.9 acres. That's 3.3 million sea urchins. We started off with an average density of the urchins on the seafloor at 25.9. We've got them down to 1.5. Our target is 2 per square meter out there. The reason for that target, if we have 2 per square meter, the kelp forest is stable in space and time. It recovers quickly from disturbance. If it was this big and then I send in a hurricane, when the hurricane's gone, boom, it comes back within 6 months to a year. So this is the magic number for us in Southern California. In Chile, it seems to be around 3. Everybody's starting to zero in on what that appropriate number, that density value for these urchins is in order to have a kelp forest that stays there. Eliminated from time to time from disturbances, but bounces back. So that explains some of the effort. This is a better look at the time that it takes to get that done. We've got little under 5,500 hours underwater getting this done. It's a big effort. And the big effort just walked into the room. I saw him. Can't believe you showed up late, Terry. Terry Herzik, right back there. Terry is the captain of the Sunstar. He has been a career sea urchin harvester. And when we started looking at the magnitude of this project, when we presented those early results that I shared with you, and I sat down with these guys to just get their feel for it, instead of just saying, hey, that's nice, kid, it was like, how can we get involved? How can we help? What can we do? And I was like, right, they know how to dive, they know how to handle urchins, and it's become a wonderful relationship. You've done a terrific job. Congratulations to you and Gary, man. It's been incredible. And this, amongst so many other pictures I'm showing you, now you know why I'm a professor and other things and not an underwater photographer. But there's the guys, you can see the hammer. They're moving along on their hookah lines. They've got, their air is coming down from the compressor through hoses from the surface. So, not from our work, but from other work, we've learned that the variance in a kelp forest really comes down to the permanence or the survivorship of an individual adult kelp plant. And it's sitting there on the rock, it grows up to the surface, it spreads out, and it sort of occupies about 10 square meters of the ocean floor. That is the sort of shadow or footprint of that kelp plant on the bottom. And whether it's there or absent in any given year is 85% of what's going on in a kelp forest. When we have years like we've had the last 2 years with El Nino, the blob, and these really strong warm water signatures or other overarching regional pressures, then the whole thing falls apart, and we see 85% plus of the variance in a kelp forest being explained regionally through the entire range of the species, from Punta Abreojos all the way up to Santa Cruz. So if we're going to monitor what's going on in a kelp forest, what do we pay attention to? On what scale? Should be 10 square meters. Otherwise, I'm going to miss it, right? I'm not going to see it. So that's what we do. Best we can, compromise a little bit, but we run out our transects, which are 30 meters long, close to 100 feet. We swim them out, and our teams count what's happening 1 meter on this side, 1 meter on that side, go out to 10 meters, start again, out to 20 meters, stop, start again, out to 30, and we systematically swim over the entire area that we're talking about and monitor what's there in advance. Then I call up Terry, actually more accurately, Heather calls up Terry, tells him where to go. He goes out there, he comes back, got it done, boom, we're back in the water, swimming it again. And so we're giving it a lot of love. And what we're able to do is plot out very accurately what the values were for the urchin densities before and the urchin densities after. So red, bad, yellow, not so great, green, still a mess at 6 to 10 urchins per square meter. And only when I get to those blue values do I have a place that research suggests will remain stable in space and time from this dynamic between urchin predation / herbivory and other disturbances and the recovery and persistence of the kelp. So we do this everywhere we go, but we didn't want to sit there and share it all with you. I mean, we sit around at lunchtime looking at it and going like, oh, yes, like, oh, do you remember this one? That one was awesome. And there are other characteristics of the landscape that we do try to collect. We're looking at the height of the rocks. We're looking at the size of the rocks that are down there because we know that they behave differently. We don't usually dive when the waves are 12 feet tall, but when they are, rocks the size of the chairs that you're sitting on are flipping around out there. And we had a few events like that over the past couple of years. And we went back and swam through an area, and 3 feet of sediment were removed. And you're like, whoa, that's really impressive. So, and again, as you know, there's many interests in the work, and there's many communities of people that we're trying to engage in this, as well as inform as to the values of our kelp forests. A lot of them already get it. In this case, a nice picture of this is Captain Terry's boat right here. This is Captain Rene Rojas's boat right over here. You guys might be able to make it out. You can see the kelp kind of in a line behind him at the surface, and then everything inside this in the cove without that kelp. And so when we figure out how to do our work, it is partly military strategies from like the Civil War. Don't get flanked by the urchins. Don't leave them behind. Back, I'm like Wild Bill sitting in the bar. I always got my back to the wall. But we honestly do that. And it's part of the secret in the sauce in this case. So in this case, these guys are going to start at the kelp forest edge, move their way inward. We're going to try to increase our area, decrease the perimeter relative to that area over time as it expands. And if we start with the kelp at our back, those kelp plants, showering forth trillions of spores, will lay down that next generation of kelp for me. And then not only are we trying to monitor things on an appropriate ecological scale, we're trying to recover them on that ecological pace, which is why the hammering works so well. If I went in there and moved too fast, something else might happen. This way, I'm trying to marry myself to the dispersal potential of the kelp. Here we are in 2015, and the kelp is back on the surface. We've got a nice canopy established. And to give you the diver's eye view of what this looks like, our colleague Kristen Elsmower, who's now working on her PhD at Davis, related work, said, I don't understand why you guys haven't shot this video before. We're like, I don't know. So she's like, I'm going to do this. You guys are so old and gray and tired. So, 0 days since urchin culling. Swim over, there it is. Urchins, not much else. In this case, even the crustose cornel algae is reduced. Now we're getting to one of our markers underwater that lets us know where we are. Going over the next set of transects 9 days later from urchin clearing, 12. So at this point, it's all the way up to the surface. It's certainly starting to attract fish. Whether we're producing fish is another function that we're very interested in informing and monitoring over time. Will tell us if we build it, they will come. I think we can say that, but if we build it, do they come and say, wow, this is a really nice neighborhood, good schools, the commute's not bad, maybe we'll just get the condo, we'll move up to a house. But if fish think that way, That's one of the things that we're trying to convince them. So a couple images on effort, a couple images on the kelp coming back, and now getting into a few more data presentations for you. And these are fairly noisy. They're a little all over the place. But these are our kelp bass on the left and our sheephead on the right. And what we can see over here is in our reference sites. So those are some of those kelp forest places that we surveyed. We see a lot of them. And consistently, between the two species, a lot of these kelp bass, a lot of these sheephead here. We see that there's few of them in our restoration sites over time, and that our controls, which are a little wonky because we've been restoring some of our controls over time, but therefore what we're sitting at this point in time still is we haven't caught up with those reference sites yet for the fish. And there's a few reasons I would suggest that that's happening, aside from the fact that they have tails and they do like to swim around. So they're moving around that peninsula. That's one thing that I think we're looking at. And we're also looking at what happened in 2015 and 2016 off of our coast. I think the simplest way I can put this to you is it was subtropical off of our coastline. We were hopping off the boat, talking to the guys from LA County Sanitation who were just down the water, and they were like, dude, you gotta look, there's a hammerhead off of Point Vicente. And I was like, yeah, we're jumping in the water. I don't have a chance to come around. That's cool. I look over, and I think it was Armin. He was like, is that a sea turtle? I was like, yeah, that's a green sea turtle. I used to work with those. And then he dropped down to the bottom, and there's a cabezon sitting on the bottom, a type of fish. And let me tell you, every number of textbooks I could stare on my shelf, on no page am I supposed to have hammerheads, green turtles, and cabezon in the same place. Things were very confused. The water was unbelievably warm. The squid that would normally mass off of Southern California were showing up in Vancouver. That's a lot of transgression. So my fish numbers, like I said, a little chaotic. The biomass, also seeing very high values in our reference sites. Maybe the restoration sites and the controls in our kelp bass seem to be coming up, but the sheephead are still certainly not too impressed with our work if these values continue to hold. As for our purple urchins, so these are the guys that we've removed 3.3 million of off of the seafloor. So their numbers have decreased in our restoration sites. Those are the yellow bars that you're looking at. Those values also stayed down in 2015, 2016. The green bars are the values that you see for them in our reference sites. So those numbers are down as well. One of the questions that this project has had to face over time is the permanence of the work. How long will this last? If you are able to knock down the urchins, how long will those urchin values stay down? How long will the kelp be stable in time and space? And I think we're looking at a good 20 years, maybe more. The small sites that we worked on off of Malibu are still going strong over 10 years later, and we've never touched them again. Red sea urchins also coming down in value and in numbers in both of our restoration and reference sites. And I think there's a couple pieces of the story that fill this in. It was super warm out there. The fishermen have come accustomed, because things haven't been so great along our mainland coast, to predominantly fish for urchin off of the islands, but that's a long trip. That's a lot of gas money. And if you're having an uncertain catch out there, it's risky for a small business. So maybe I'll fish along here in PV during these uncertain years, and guess what? The urchins were getting better, and I know that the urchin fishermen knew where we were, because we kind of were like, hey, weren't we just there 6 weeks ago? Yeah, we were, right? I wonder what those three guys are doing over there. Thank you for the urchins, Tom. Shoving them in the basket. If that's indeed happening, that would be great, and we'd be very pleased with that. What we see is giant kelp, the competitive dominant, the basic biogenic structure that anchors this ecosystem to the reef, and there used to be none, and now we're getting up towards our expected values for their presence. We're looking for 1 every 10 square meters out there, an adult kelp, and we're getting very close. So we'll see how that holds out over time. And again, let me underline the oceanographic conditions out there. Positively unfavorable for kelp growth. Too hot, low nutrients, all of that noise. You can see that the values came down for the reference sites as a response to that. But we saw growth in the restoration sites nonetheless. So that's where I get back to that ecological versus overarching physical driver. And we can't forget this. For anybody that's paid attention to the ocean off California as closely as we have over the past few years, you may have heard that all the sea stars died. And it was close to true. And all the way from Alaska down the coast into Baja, California, the sea urchins, the sea stars were just gone. And they went away over the course of 2 years. And then subsequent to that, about 1.5 years later, we started seeing urchins that looked like this. Spines would fall off, large open ulcer all the way to their test, to their endoskeleton, and then typically a secondary infection that would grow into the main cavity of their body. And at that point in time, the animal has really no choice to fight these infections. And they died off of the Palos Verdes Peninsula by the tens of millions. And they died by the hundreds of millions up and down the coast of California. And so some of the numbers for all these guys have come down over the past year because of that. Happy to say we saw that in the fall of 2015, and that we stopped seeing urchin wasting in the spring of 2016. We put everybody on hiatus while this was happening. We sat back and monitored, and then once we finally saw that the wasting event had gone by, that the urchins were still in densities greater than 2 per square meter, is when we finally started moving back out into the water again to restore these areas.
What was the cause of that?
Don't know. There was a virus that was ascribed to what took out the sea stars. We know that it was a virus that they had experienced before and had some die-off on a large regional scale back in the 40s and 50s, but it was nowhere near as virulent as it was this time. So we don't know why it was so especially lethal. And we didn't get to these fast enough to even find out. So this is my first time trying to interpret this plot because it's brand new. What we're looking at are the circles represented on this plot that if we go back in time, the circles become more and more transparent. The closer to 2016 we arrive at, the more solid and opaque each one of those circles is. The green ones represent our reference sites, the controls, red, and our restoration sites in blue. And what we can see is that back earlier in time that the reference sites cluster out differently than the control sites and the restoration sites. What we can see is that the restoration sites start to move to be more like our reference sites earlier than the controls, and that the controls follow that in time, and we ascribe that to that wasting event. This is whether we hit them with a hammer or if the wasting event takes them out. Their numbers are going down and their pressure is being released. And what I can tell you that we haven't had a chance to quantify yet, but my observations, and I think the others of the team would suggest, is that the urchins that we left behind, be they valuable to the fishermen or not, they had greater survivability to this wasting event because they were in good condition. And these poor animals that have had no real nutrition were in a poor physical state, and when that disease hit, it disproportionately affected them, and we saw much greater percentages of loss in there. Here's a few bar graphs, and I don't want to get you buried under all of this, but our restoration urchins and our kelp urchins are starting to look, our restoration urchins are starting to look like kelp urchins and not like barren urchins. So we're happy about that. And if we start to plot them out over time, and these are values from 2014 before everything really got funky thermally off of our coast, that we can see that if the red urchins are in the barren, they're still barren urchins, right, from that old plot I showed you with the red line. The green urchins being in our reference site, still looking like kelp urchins, and the blue ones being our restoration urchins are looking much more like kelp urchins. So once again, we feel like we're on the right track and that we're having some success. Here it is for the purples. We're starting to see the same thing, barring the larger sizes where the ones in the kelp forest seem to still be doing a bit better. So that's kind of where we've been. Let me tell you where we're at and where we're going. So this event off the coast was profound, and it was a shakeup, and it has members of the scientific community discussing, is that something that we can expect to see more often? Is that perhaps a flash forward to what the new normal will be in some years off of our coast? And we know that ocean acidification has already impacted the Puget Sound area profoundly, that it's materializing off the coast of Oregon in a very profound manner, and we don't really have a great handle on it off of our coast yet. So we just found some money, threw a bunch of really expensive stuff into the water to find out if acidification is manifesting here. If it is, how fast it is. We're working with a bunch of folks up and down the coast to help us inform that question. How quickly are our oceans decreasing in their pH values? Sediment transport off of our coast. We paved it over, we've compacted it, things aren't running the way they used to, and certainly that would flow out off of the beach and into our near shore. What can we learn about sediment transport, and can kelp forest restoration help retain sediment and help us keep our beaches and the toes of our cliffs and things like that more resistant to erosion? And can the kelp forest play a role in that? Wave energy attenuation. If the kelp forest is there and those massive kelp forests are sitting in the water and the wave has to push through them, do they actually have the ability to lessen or absorb some of that energy and decrease the hit of that wave on the coastline? Sea level rise, certainly predicted to happen. Does the kelp that we're producing lead to more rack building up on the beaches? Are there other management strategies? Other projects that we have going on right now are focusing on beach restoration and dune restoration so that we can make our beaches taller, so that as the ocean comes up, we're safe behind them. And warmer water being something that is a particular concern for these kelp forests, as when the water's warm, the water's nutrient poor, the kelp doesn't get the food it needs, it can't grow. So we'll be paying attention to all of those. And we are working with a diverse group of people. Right now, questions 1 and 2 come from our good friend and colleague, Kristen Elsmore, the videographer, swimming the timeline. Do kelp forests dampen wave energy? How do kelp forests influence current flow and stratification? If I slow the current down, the water won't take the sediment away. Maybe it stays closer to the coastline, and maybe we don't have these erosional factors contributing as strongly. We just brought on a group with the Institute of the Environment and Sustainability at UCLA. Hello. And they're helping us with a couple of their faculty members really try to get after number 3. So if kelp is as productive as it is, if it's pulling down the CO2 out of solution, does it have the ability to locally buffer the manifestation or the effect of coastal ocean acidification? And if that's true, I don't know, you guys are going to tell me in a couple months, then these are refugia up and down the coast where animals might be able to duck into and get a relief, or where they might be able to live out their whole lives and not be impacted as profoundly. So this has required some new toys in our life. We now have acoustic Doppler profilers out there, pressure sensors, thermistor strings, where we're taking these various measurements of the environment to see how they change. So if there's no kelp forest, it looks like this. We smash away, things change, the kelp forest comes back. What does it look like at that point in time? Many of these studies have had to take place in different places. The artifacts creep in, the variables increase. We've got a really nice, tight experimental model. And now for our abalone. Chances are they're not going to come back even if we make the kelp forest better. They are too few and far between. And fishing protections alone, meaning a complete ban on the harvest of them in Southern California, is probably not going to get it done. We're working with NOAA, with National Marine Fisheries Service, with a number of state agencies and researchers in a growing network to figure out what we can do to put the abalone back. Because this picture is informative. They compete with urchins for space and for food. So we can talk about, oh, predators and trophic cascades. Competitive relationships can also lead to better control of these urchins over time, lead to more permanence for our work, and help save these beautiful, tasty abalone. So we started harvesting abalone off the rocks, bringing them up into the boat, setting them through a method that's intended to stress them to the point where they're like, I don't think I'm going to make it. So I'm going to get rid of my eggs and my sperm while I have a chance. And so, you know, aren't we sweet people? Like, wow, Tom, great talk. Murdering things with hammers and torturing abalone. I wonder what he does to dogs. And we especially love this opportunity because most of the abalone restoration work at this point in time has been take abalone, bring them into a lab, raise them up. Takes years. It's very expensive. There can often be very low survivorship of the outplants. What if we just skip all that and get right down to what Mother Nature, perhaps for lack of a better term, would do, which is get the larvae and get them back out onto the reef. But I have to go back and find them. Otherwise, I can't prove anything. So how do I keep a bunch of microscopic planktonic larvae in one place? I hang on to them for a few days. I wait for them to mature. I stick them inside a plankton net that we've weighted down with lead chain and a float, and I inject them with our big fancy PVC syringe. So in this case, we're sticking 50,000 larvae into this tent in the bottom of the big kelp forest tank at the California Science Center Foundation. The kids were outside just banging on the wall. Oh my God! And then we were able to turn on the surge machine there, which makes the waves, so that we were able to see, you know, does the tent stay put? Does it seem to lift? Are we actually getting the control of the advective and convective currents that we wished for? We've now built a laboratory down at the Southern California Marine Institute. A lot of the research that's going on there is being supported by California, Cal Poly Pomona, faculty and grad students. And here we are feeding our abalone. Oh my God, they're worse than pigs. I've never seen something eat so much as abalone. Here's one spawning, and here's your basic, you know, embryonic stuff. 1, 2, 4, 8, 16, and abalone. And we've also conducted some trials with juvenile outplanting. So I said that we're interested in these larval outplants. Juvenile outplanting has been successful. I think we're going to continue approaching this. And what we've realized is that if we, who aren't afraid of doing thousands of hours of work underwater, are willing to work in these very complex habitat types, where we're ensuring high survivorship because it's cryptic. There's lots of hiding places. There's lots of food that we might actually get our survivorship values for our juveniles up around 85% or so. So that is a project that's a ton of fun. What you can't make out in that right-hand picture, unless you've got better eyes than I do, is this is a 150 abalone pouring out the end of this pipe. And we had no idea how long it was going to take. We were like, okay, have you done this before? Have you done this before? Are they going to know to get out of the pipe? Like, I don't know, man, we might be here for hours. Forget it. Shove the pipe in, pull the net off, pouring out the end of this thing and into the rocks, seemingly absolutely overjoyed at the opportunity to do so. So as I had mentioned, I am standing here as one person presenting you the contributions of tens of people and multiple institutes up and down the coast. Can't say enough about the warm welcome that we've had and the 10-year relationship we've had here with the Center for Santa Monica Bay Studies at LMU, our colleagues at UC Davis, Occidental, Cal States, and a number, they're up there, state and federal agencies that have provided us with expertise as well as permitting and regulatory control of our work, the folks at the Montrose Settlement Restoration Program that put the core funding on the table for us to do this, the folks at USC and California Sea Grant for helping us with the funds to find some of those questions that our baseline restoration funding was otherwise not going to get at. And once again, and due credit to, again, Heather Burdick, who's done a terrific job over the past years. I think these were your first babies right here. And you'll get to meet her. She's a normal-sized person. You know, this is not freaky or anything. But, you know, so that, you know, wonderful, wonderful system to work in, a great opportunity. And again, I thank you all for coming out tonight.
for some Q&A in case anybody wants to go ahead and fire away. So I'll bring a microphone around, starting with Carol.
What about the sea stars? What's going to happen? Is there any hope?
I think there is some hope. What we learned last time was that it took a decade or two for them to return back to their past size and density up and down the coast. We are seeing a lot of little babies creeping out of the rocks. On occasion, I'm seeing a few adults that are out there, so all of that is encouraging. And if the water continues to cool down and stays cool, maybe some of them that are really tucked down in the rocks or crawled offshore to deeper waters, maybe back in their normal depth profiles. We'll find out. But that's about where we're at. Everybody's kind of fingers crossed and happy that things seem to have stabilized. At least some are coming back. Please.
Do the,
Wait,
the-
wait.
I'm sorry.
What am I?
Oh, no, I don't think I need.
Well,
It's because we're capturing that.
Oh, okay, all right. Do the purple spiny urchins have any commercial value other than sushi or gonads or?
A few people have tried to come up with alternative market valuations for them. So, geez, man, like, you know, just smash them. Isn't there something you could do with them? There is sort of cottage industry approaches towards including them in composting streams. They've got a really nice signature for compost. They've got some good nitrates, phosphates in their tissues. The calcium carbonate, which makes up their skeleton and their spines, great for buffering your soil chemistry. But you also have the problem that you're now trying to work through your garden and it's full of spines. So perhaps they can be crushed up into something else. I see them pop up in a few products every now and then, like, oh, you need to have this, you know, magic urchin serum to help your longevity. I don't know if that would actually work. Surely the red urchins are of value at this point in time. Trying to figure out if there's a way to come up with marketable purple sea urchins is something that we're in conversations with a few folks in Japan and Norway who don't have our purple urchins but have green urchins, which are sort of in between our reds and our purples in size, and maybe there's a way to lead them to production for that purpose. Dr. Dorsey, Taylor.
Well, just real quick, Tom, why don't you discuss how quick these kelp plants can grow?
Happily, I may have skipped over that. So a giant kelp plant, once it reaches adulthood, and in that case I would say it's maybe about 15 of those stipes, the sort of rubber band looking thing with all the blades coming off of them, and 35, 40 feet in length. When conditions are right, sun's right, water temperature's right, the nutrients are good, that thing can slap down 2 feet a day. Nothing grows faster than we know of. That's an impressive rate of growth. That's serious carbon pull, and really illustrates some of the reason why we're starting to figure out why what has been, from a productivity standpoint, measured out to be the most productive ecosystem or ecotypes on the planet, and why we might be interested in them and furthering their growth and management to help us with our carbon on a global scale.
Do you expect to face any challenges moving forward with the new administration?
Do I expect more challenges than the ones that have already arrived, Taylor?
That was quick. Both.
Okay, here, I can tell you right now, our National Estuary Program, we are one of 28 around the country, received notice through the news wires and several phone calls today that future grant funding for programs like ours is currently frozen. So we may be able to finish out our current life cycle, and that would take me to the end of this current federal fiscal year, which would be September 30th, but after that, we may be done. It is roughly a third to a half of our funding for our program that arrives each year. So, that's the start. There's stuff that I saw on the internet that I can't necessarily support as to its validity, but government scientists like loading stuff onto their hard drives to try to get it out of there before it may become that it was here. So, yeah, I think there's some profound changes. I'm also quite hopeful that a bunch of people who might not have looked at one another as united as we should might sit there and say, wow, I really don't like where this guy's going. And I'm quite proud of the state of California because the legislature's been really beautiful. I think they've told them this is not us, pretty flatly. And we've got a lot of power in this state to push back, so we'll see where it all ends up. I know I fight lots of stuff all the time. I think we'll be good to go. But, good question. Yes? Oh, Ray's getting his steps here. 564 for the day.
What caused the huge spike in the urchin population in the first place? That kind of spurred the
Right.
need for this? And like, why is it going to be a continued problem even, say, 20 years from now, that there will need to be future restorations?
Excellent. And some of you may want to start walking out the door because this goes for like 40 minutes. So when we take out the predators of a system, like has happened due to past overfishing efforts and really ecologically insensitive harvesting off of our coast, then those urchins become more numerous because they're not being depredated. And that comes down to sea otters back in the mid-1800s, locally extirpated here. They used to exist all the way down into Baja. A lot of folks just think of them as Central Coast, but they were all the way down here. 45-pound hydro weasel, vicious beast, eating 25% of its body weight in urchins a day, gone from the system. If we don't leave the big lobsters behind and the big sheephead behind, our existing predators aren't large enough just simply from a trig or geometry level to actually predate the urchins. But again, don't predate anything that's not worth eating in the first place. So that was a part of it. Excess nutrients being put out into our coastal environment lead to enhanced survival of these larvae who are pulling the nutrients out of solution at that point in time. We've seen that here. It's not been really tested too much off the coast of California. The crown of thorns starfish was the sort of hallmark for that in Australia, where they saw eutrophication in their coastal bays. It enhanced survivorship and enhanced recruitment onto the reefs, and the crown of thorns were just devouring the reefs. So those are two of the biggies. So if we continue to clean up the pollution stream, stop sucking up the ocean and sterilizing it, and allow some room for these predators to come back and reset the clock, I think that we can sustainably use the kelp forest off of our coast, that it'll be stable in space and time, and that has been our legacy. I don't know how often we think of ourselves as Californians going back 20,000 years, but that's pretty much the history of Homo sapiens off this coast. And John Erlandson and his team at the University of Oregon figured this out a long time ago, and he said, you know what, man, the first humans didn't come here walking in between a glacier and a frozen coastline chasing mammoths. They followed what they called the Kelp Highway. We found their boat building, their basket making, their hooks, and all those techniques, and it looks like the first Americans were folks that had been accustomed to harvesting out of kelp forests in northern Japan and Siberia, made their way across the Aleutians and came down our coast. So I think we've had a blip in time. This is not going to be our proudest moment of coastal management, but I think we can get it back, and hopefully 20,000 years from now, somebody will be standing probably in a new library at that point. But hopefully having much of the same conversation of, yay, look what we did.
Any more questions? If not, at this point, I'd like to thank Professor Tom Ford one more time.
Okay.
Thank you. I'd also like to thank Professor John Dorsey for introducing our speaker for tonight. I want to thank thank you. I also want to thank my outreach teammates, John Jackson, Carol Raby, Mario Gallardo. Thank you very much for helping us plan tonight's event, and thank you to all of you for attending tonight's event. There's plenty of food and drinks to go around, so we have the room until 7 o'clock, so please feel free to mingle and just hang out, talk to the speaker for tonight, and again, thank you. If you have those feedback forms, again, $100 gift card if you want one. After you complete them, there's a plastic box on the counter. You can slip them into that box once you're done with those forms, okay? Again, good night, everybody. Thank you.
Thank you. Has the recent rainy winter caused any difficulties, or is it good for it? Or?
The rainy winter